Hello students, I am Tejaswini, lecturer in ENC, SJ Government Polytechnic, Bangalore. And we are studying the Unit 2 of 8051 microcontroller, that is instruction set and assembly programming of 8051. In the previous sessions, we have studied the addressing modes. We have studied the 5 different addressing modes, that is your immediate, register, direct, indirect and index addressing modes. Then we have started with types of instruction set. We have studied the data transfer instruction set. In the data transfer, we have studied about the move instructions, how to transfer the data from by using the different addressing modes. Then we have studied the arithmetic instructions for addition, subtraction, multiplication and division, how we are going to represent and what is the syntax with examples. Then we have studied the logical instructions. This is for and or not. Okay. Then rotate instructions. If you want to rotate left and right, how we are going to use the instructions in the program. Then we started with the jump instructions. In the jump instructions, we have studied the conditional jump and unconditional jump. Conditional jump means what? In the condition jump, here there will be a condition. Then it will jump to the particular address. Else it will continue. In the unconditional jump, without any condition, it will jump to the your specified address. Okay. So in the we have studied what are the different ranges for jumping the instructions. We have seen the 3 different ranges. It is relative range from minus 128 to plus 127D, and then we have seen the absolute range, that is from 0000FH to 07FFH. Then we have seen the long range, that is from 00000 to FFFH, from 0 to 64K. That is your program memory. Understood? Then after that, we have seen the unconditional jump instructions. In the unconditional jump, we have studied the 3 different instructions. That is your L jump, A jump and S jump instructions. Okay. And after that, we have studied the conditional jump instructions. The conditional jump instruction, there it will change the program flow if the condition is met. Understood? Else it will continue with the next instruction. There we have seen GC, jump with carry, jump if not carry is equal to 1, like the JB, GNB, CJ and Z. Understood? We have seen the different conditional instructions. Now, today in this session, we are going to see what are the call and return instructions. Then we'll do some multiple choice questions. Call and return instructions. This is another control transfer instruction, is the call instruction. Here we are using the call instruction in 8051 to call the subroutine. See, sometimes what happens is we need to call the same subroutine. We need to use the same subroutine. Instead of putting a number of times, what we will do is whenever we want, we call that subroutine, so that we can reduce the memory space for the program also. Understood? So subroutines are often used to perform tasks that need to be performed frequently. This makes a program more structured in addition to saving memory space. See, if we want to write the subroutine, same subroutine 100 times means we can't write 100 times in the program. Instead of that, what we will do, we will call the subroutines, okay, number of times, so that we can reduce the memory space. Okay. So in the call, in the 8051, there are 2 instructions for call. One is L call and the another one is A call, that is long call and absolute call. Then we are also having the return instructions, that is RET and RETI. Then NOP is no operation. Now we will see one by one in detail. Okay. First one is lcall. Lcall means long call. See, already we have seen the long jump also. Okay. So, long call. See, in the long call, it is 3 byte instructions. In the ranges only I have told you. For relative range and absolute range, it will be of 2 byte instruction. For long range, it will be of 3 byte instructions. So, this is the 3 byte instruction. The first byte, it will be the opcode, and the second and third bytes are used for the address of the target subroutine. So second and third bytes, they specify the target address. Understood? So next, lcall, it can be used to call subroutines located anywhere within the 64 byte address space of 8051. This is long call. So this is the long range. The long range, it will ranges from 0 to 64 bytes. That is your 0000H to FFFFH. Okay. So whenever a subroutine is called, so when we call a subroutine, what happens? The control, it is transferred to that subroutine. Okay. And the processor saves the PC on the stack and begins to fetch instructions from the new location. See, when you call the subroutine, what happens? The control will go to that subroutine. So again, it has to come back from the subroutine, right? Then where it has to come back? So it has to save the address in the stack by using the stack. So since it is a 3 byte instruction, so here your PC will be incremented by 3. Okay. And the address, the 16-bit address, it will be stored in the stack. First, the lower address is stored and then the stack will be incremented. Then your higher address byte is stored in the stack. Okay. So while retrieving, first higher byte will popping, what we will do? First higher byte will be popped, then a lower byte will be popped. Okay. This is after the return instruction. So this is what happens. So and the processor saves the PC on the stack and begins to fetch instructions from the new location. So after completing the execution of the subroutine, what happens? The instruction return, RET, it transfers control back to the caller. That means to the main program. It will return to the main program. See, there already we have saved the address of the next instruction in the stack. So by using that address, your control will come back to the main program. So every subroutine, it needs RET as the last instruction. All subroutines, it will end with RET. That means it is the end of that subroutine so that it will return back to your main program. Understood? Next, let us see an example. See example. Your stack pointer is pointing at 07H. Okay. And the label subroutine. So this is assigned to a program memory location. This subroutine, it is having the memory location 1234H. So after executing this lcall subroutine instruction, this is at the location 0123H. See your stack pointer, initially it was at 07H. Whenever you call the subroutine, your stack pointer, what it will do? It will save the address of the next instruction. Since it is a 16 bit, so here the stack pointer will contain 09H. It will be pointing. So here 08, that is internal RAM locations 08 and 09H, it will contain 26H and 01H address. Understood? And your program counter will contain 1235H. That means this is the address of the subroutine, the next instruction that is to be executed. Always your program counter will contain the address of the next instruction that is to be executed. Understood? So here whenever this will call, the next the address here, it will be saved in the stack, then it will go to the subroutine, then it will execute. After the return instruction, it will come back here. Okay. Then next one is your A call. A call is the absolute call. A call, it is a 2-byte instruction. Your L call is the 3-byte instruction, but this one is the 2-byte instruction. The target address of the subroutine, it must be in the range of 2k bytes, because only 11 bits of the 2 bytes are used for the address. As already we have seen in the A jump also, only 11 bits are used for the address there. Okay. So there is no difference between A call and L call in terms of saving the PC on the stack or function of the return instruction. Everything is same, only here the range will differ. Okay. And the byte instruction, that is of 3 byte and this is of 2 byte. The only difference is that the target address of L-call can be anywhere within the 64K address space, but A-call, it should be within the 2K byte range. If we consider an example, same thing just like your L-call, here initially it is stack pointer is at 7H. So next the subroutine, it is at the location 0345H. After executing A call subroutine, that is at address 0123H, your stack pointer will contain 09H because it is a 2-byte instruction. Your address is 11 bits. So 08 and 09, the data will be pushed into this stack locations. Okay. Then the PC will contain 0345H. That is your subroutine location. Understood? So, it will jump to the subroutine. Next, return instructions. Already I have told you, for every subroutine, it has to end with a return instruction. So, it will, RET means it will return from the subroutine to the main program. Syntax, we will just write it as RET. RET is used to return from subroutine previously, that is called by the L call or A call. Okay. Program execution continues at the address that is calculated by the popping the topmost 2 bytes of the stack. See, whenever we call a subroutine, we are saving the address of the main program flow. The next instruction will be pushing into the stack. While returning, it should be popped from the stack. First, we will retrieve the higher byte, then the lower byte is retrieved. Okay, the most significant byte is popped off the stack first, followed by the least significant byte. Remember, every subroutine, it has to end with a return instruction. Then only it will return to the main program. See, if we consider an example, the stack pointer originally contains the value 0BH. That means the two locations, it will be 0A and 0BH. So, in this, first the data present in the 0BH is retrieved, then from the 0AH is retrieved. See here, RET, after executing this instruction, it will leave the stack pointer equal to the value 09H. So program, because we are retrieving the two locations, right, 0BH and from 0AH. So it will be, its stack pointer will be at the location 09H. Understood? So program execution, see first what we will do there, the 0AH, that is location 0H, we are having 23H and BH, we are having 01H. So first is MSB, 01H will be retrieved, then 23 will be received. So the memory location will be 0123H. Next, RETI. RETI means return from the interrupt. Understood? Syntax is RETI. RETI is used to return from an interrupt service routine. If we are using or if we are calling any interrupts, to return from that interrupt, we are using the syntax RETI. RATI first, it will enables interrupts of equal and lower priorities to the interrupt that is terminating. Program execution continues at the address that is calculated by popping the topmost 2 bytes of the stack. Okay. The MSB is popped off the stack first, followed by the LSB. If we consider an example, the stack pointer originally contains the value 0BH. An interrupt was detected during the instruction ending at the location 0122H. So it is 0BH means the internal RAM locations from where we have to retrieve is 0AH and 0BH. It contains 23H and 01H respectively. After executing RETI, your stack pointer will be pointing at 09H and then your address location will be 0123H, just like your return. But there RET it is for subroutine to return from the subroutine, and RETI is to return from the interrupt. Next one is NOP. NOP means no operation. Execution continues with the following instructions other than PC. In this, no registers or flags, anything is affected. Okay. So if we consider an example, it is designed to produce a low going output pulse on bit 7 of port 2, lasting exactly, it should have 5 cycles. So a simple set bit or clear sequence would generate 1 cycle pulse. If you are using set bit or clear, you can generate 1 cycle. So if you want to have a 5 cycles, then what we can do? We can use this no operation. See here, clear P2.7. Okay, so here it will clear the bit 7 of the port 2. So here they are telling that it should last exactly for 5 cycles. So then what we can do is, if we add no operation, here this is 1 cycle, so that it will be having the delay, it won't execute anything. So whatever it is there, so in this instruction whatever it is executing, it will continues. So here this instruction, it will continues for 5 cycles. Then again set bit P2.7, then the 7th bit of the port 2, it will be set to 1. If you want to continue the same instructions for more cycles, then you can go for no operation. That means we are not doing anything, we are just continuing with the last instruction. Okay. So for adding delay and all, okay, if you want to add delay, then we can go for this no operation. Understood? That you will come to know when you will solve the problems in the serial communication, okay, and IO port programming. Okay. So these are the call and return instructions. So we have studied in the call, we are having L call and A call. Okay, long call and this one short call. Understood? Then for the call, we should the subroutines, it has to end with return instruction, that is RET. And we are having one more we studied, RETI, that is return from interrupt. For interrupt, whenever we are calling interrupts, it has to end with RETI instructions. Then NOP, that is no operations. If you want to add a delay in your program, then you can go for NOP instruction. Understood? Now let us solve some MCQs based on this. Which of the following statements is true? Call instructions is used to transfer control anywhere in the 4M memory space. Push instructions is used to take out the value from the stack into some register. Pop instructions is used to jump into any location. RCall is a 4-byte instructions. See here, read the statements properly. See, call instructions is used to transfer control anywhere in the 4M memory space, that is 4 mega, that is your 64K. Push instruction is used to take out the value. Push is, what we are doing is, we are not take out, we are putting the value in the stack. Pop is to take out, it is not to jump. RCall is not there. Understood? So option is A. What kind of instructions usually affect the program counter? Call and jump, call and return, push and pop, return and jump. Your PC, it will be affected by call and jump instructions. Understood? The instructions that are used to call a subroutine from a main program and return to the main program after execution of the call function are, which instructions you will use? Call jump, jump IRET, call return, jump return. Always call and return both should go hand in hand. That means if you are calling that, then at subroutine it should end with RET. Okay. Lcall instruction takes dash bytes, 2 bytes, 4 bytes, 3 bytes and 1 byte. Lcall, long call, it is of 3 bytes instruction. Your A call is 2 bytes instructions. What does the last instruction of each subroutine that transfers the control to the instruction in the calling program with temporary address storage called as jump to subroutine, branch to subroutine, return from subroutine, then call subroutine. The last instruction for each subroutine is return, RET, that is return from subroutine. When the call instruction is executed, the topmost element of stack comes out to be the address where stack pointer starts, the address next to the call instruction, address of the call instruction, next address of the stack pointer. See, when the call instruction is executed, then it will automatically jump to your subroutine. So the address next to the call instruction. Okay. So I hope you understood this topic call and return instruction. While doing the programs, you will understand much more better. Thank you for listening.